Assalamu'alaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Althaf, representing Group 2 of the English class from the Architecture Study Program Class B. In this video, we would like to present our video assignment which covers Unit 3 about materials and Unit 4 about equipment. Enjoy the video.
At the engineering campus, a group of students, Rizki, Risma, Ladya, and Althaf, are in the cafeteria discussing creative ways to use everyday tools for their project.
Alright team, we need some creative ideas for using this tool. Let's start with the car battery.
The car battery can be used for more than cars, like powering a mouse, solar project, or as backup energy.
Yeah, we use one to power the water pump during our irrigation project.
True. We can also charge small devices when we're attempting for research.
Good point. Now what about the tape measure?
That's an easy one. It's useful for measuring materials when building prototype engines.
And for designing small-scale mechanical models, precision matters.
I even use it to measure my dorm room before buying a table.
Haha, that's practical. Okay, next, speed level.
It helps keep structure balance, like our bridge model.
It also can be important in architectural or interior design work.
Yeah, even handy if we ever open the cafe or shelves are tilted.
Good thinking. Now let's on the wheelbarrow.
It's not just for compact workers. We can use it to carry heavy light materials or tools across campus.
True, we use one to move cement bags and soil during community service.
It's great for environmental projects too, like collecting trash or carrying plants.
We some ideas. Let's read this down for tomorrow.
Agreed. We'll use such simple tools that be so useful for college study.
It just shows that creativity makes ordinary tools practical.
Arif, a construction worker, sits on a pile of debris wiping his sweat. Yogi is walking down the street near a construction site when he spots his friend sitting and resting after a long day of work. Beside Arif lies a jackhammer. Curious about the unfamiliar tool, Yogi approaches, greets Arif, and starts asking about the tool.
Hey Arif, you look really tired. What happened you been working on?
Hi Yogi, I've been breaking this old concrete floor since morning. Luckily this jackhammer helps a lot.
Jackhammer? What did that?
It's a powerful tool for breaking concrete or asphalt. It uses air or electricity to move chisel up and down very quickly.
Oh, so it irate a strong version of a chisel.
Exactly. It breaks hard surface in minutes instead of hours.
That's efficient. But is it heavy?
A bit, but just guide it. The machine does the hard work.
Nice. Then politics pay.
No problem. Just remember to wear ear protection. It really now.
It's a busy morning at the construction site. The workers are preparing their tools and checking the equipment before work begins. Suddenly, they find that some of their equipment has been damaged.
Hey, come here for a second. Look at this wheelbarrow.
Oh, what happened to it?
The wheel is totally bent and one handle is broken.
Seriously, that looks bad.
I think a truck hit it when it's parked near the bumper of the wall.
Oh no, there is even a big dent on the side.
Exactly. Do you have any hint who did it?
Maybe the Delphi guy. He parked his truck too close this morning.
Makes sense. Poor wheelbarrow. It's been through a lot. We might need to buy a new one.
Anyway, that's not only the problem. Look at the pipe. It's also broken and leaking all over the road.
Seriously? What happened there?
They are three smart design. I think a car could run over it. It was left unprotected, so it's broken easy.
Dread. A broken wheelbarrow and a broken pipe. What a day.
Haha. We should call maintenance before the boss find out.
Good idea. Let's fix this mess before it gets worse.
One bright Monday morning, in the spacious lobby of the newly built architecture department, a student named Risma spots Mr. Arif, the architect who designed the building. The lobby is bright with natural sunlight streaming through the glass walls. A few students are passing by, holding their design models and drawings. Mr. Arif is standing near a display model.
Mr. Arif. Good morning, Mr. Arif. May I ask about building maintenance?
Of course, Risma. What would you like to know?
What's the difference between maintenance and repair?
Maintain means keeping things in good condition. Repair means fixing something that already broken.
Can you give me example?
We maintain the air conditioner by cleaning it regularly, but if it stops working, we repair it.
Oh, I see. Thank you, sir.
You're welcome, Risma. Good luck with your studies.
The morning atmosphere in the office felt urgent. The main door of meeting room suddenly broke down. Exactly 15 minutes before an important meeting with a client was due to start. Yogi, the supervisor, immediately rushed to the technician area to find Arif.
Hey Yogi, come here. The door in this corridor is broken. Please fix the thing quickly. Understood. Sir, you'll get the tool. First, check and tighten the screw on the thing. Start from the top. What if the screw are worn out and loose? Use the wood plug and glue trick to fill the hole. Then put the screw back in. Ready after they are all thick. Lubricate the thing with little anti-rust lubricant so it doesn't squeak. Don't overdo it. Okay, finally. Is the door function? Correct. Make sure the door is straight and smooth. Report back when finished. Understood, sir.
That morning, in the architecture studio at Muhammadiyah University of Jakarta, three students, Althaf, Hasan, and Ladya, sat around a large table filled with laptops. They were having a casual discussion for an assignment in their construction technology course. On the screen, a video documenting the construction of the Shard, London's famous skyscraper, was displayed.
1,016 feet, the Shard in London is taller than the Eiffel Tower. It has 72 habitable floors, 44 elevators, and 306 flights of stairs. Building this mega tower required almost 2 million cubic feet of concrete.
So we're talking about the Shard today, right? The super tall building in London. Yeah, we're supposed to explain the main equipment they used during the construction.
From what I read, there were 4 main tools: cantilever loading platform, concrete pumps, jump lift, and cranes.
What are cantilever platforms? They are like temporary steel balconies used to move heavy material from outside the mill.
It saves space inside and makes the process faster.
Makes sense, especially in a tight area like central London. And it's safer too. What about concrete pumps? They use pump to move wet concrete from the ground all the way up to high floors.
Imagine doing that manually. No way!
I heard they pump 90 cubic meters per hour. That's insane. It saves so much time and manpower.
Next is the jump lift. It's an elevator that moves higher as the building grows.
So, workers can go up and down even when the building isn't done yet. Exactly.
And of course, the crane, the most iconic part of any skyscraper project.
I can't imagine how they managed the height without one. The crane was lifted like Aaron every time the floors was added.
That's pure engineering art right there.
So basically, this force was made the whole construction possible. Yeah, they are like the backbone of the project.
It shows how innovation and engineering must go hand in hand.
It's a warm afternoon at the cafeteria. 3 workers preparing for their construction technology discussion are deep into analyzing how the top crane of the Shard was dismantled, a process that combined precision and innovation. On the screen, a video documenting the construction of the Shard, London's famous skyscraper, was displayed.
The giant slip-form rig measured 85 by 72 feet.
It was moving upwards at 3 meters a day, almost a floor a day. You have steel shutters which form the shape of the concrete, and then they're moved up almost continuously, 6 days a week, 24 hours a day.
Thanks to a high-capacity concrete pump, the system was so efficient it reached the 21st floor in just 10 weeks.
I've been thinking about how did they remove the hoop can on top or of the sun.
Good question. They use a smaller crane called the derrick crane placed right on the roof. Yes, it's fascinating. The briar crane was used to dismantle the main tower crane piece by piece.
So, a small can took apart the big one.
Exactly. It's called the sectional dismantling method. It keeps the structure stable, and it makes the load easier to control.
What happened after the big cart is built?
Yeah, the derrick crane is also taken apart, and its parts are broke down using the surface wave.
Why? So the carry can remove itself?
Pretty much. It's a bit ironic. It's not it? Yeah. But the engineering efficiency, low detail, and safe.
I read that this method helped avoid vibration or imbalance on the after structure.
True, is maintenance core stable during the process. And it reduces risk for workers' sales that don't stay at the high point too long.
A great example of smart risk management in tall buildings.
Excel, every move is calculated. This, why engineering is not just math, it's about prediction, precision, and trust in the teamwork.
You'll say, I guess that what makes the shark suit and its fishing project.
Three students gather in the cafeteria. Laptop and iPad reports are scattered across the table. The mood is reflective. They are discussing not only the shard's technology but also the lessons it brings for construction innovation in Indonesia.
So, beside the mains to like crane and palm, what other equipment do you think they use on the site?
I would say scaffolding and safety nets are must have for any high-rise projects.
Totally, and probably tower heights for workers and material movement.
Oh, let's concrete mixture and rebar cutters. Basics but important.
They also use GIM, right?
Yes, beam help coordinate design and seize work value errors and improve triggering.
No wonder the project went smoothly. Technology and teamwork work together.
Yes. Beam with safety management, how it does incident.
That's true. Beam keeps all information in on place so everyone use the same data.
It's all about integration.
True. Efficiency is not just speed, but reduction was an increasing safety.
The so in innovation is not just advanced tools, but using them wisely.
Oh, I think we can apply the main site in Indonesia to especially for skyscraper in Jakarta or Surabaya.
Challenge is adapting modern methods to local resources
and building a culture of collaboration between design, engineer and manager.
That's true. Future of construction human skill supported by technology.
One day we will build scientific connectivity.
Why not? We just have to think correctly and bit.
It's another productive morning at the construction site. There's a table with documents and a notepad. Ilham is curious about how the ordering process works and asks Ladya to explain.
Hey, I'm Chris on a house project. How are building material usually ordered?
It's pretty simple. First, the contractor or site manager makes a material request form listing items like cement, sand, and bricks.
Got it. And who handled the actual order?
The purchasing staff. They check the list and send a purchase order to the supplier. After the supplier confirms, they deliver the materials with a delivery note.
So, the document progress the material were etc.
Exactly. The site manager signs it after checking everything is correct and in good condition. Then a copy goes to the office for records and payment.
Makes sense. So even for a small house project, you still need proper document like the material request form, purchase order, delivery, note, and invoice.
Right. It helps avoid mistakes, missing material, or double orders.
One afternoon, in the campus study area, Arif and Risma are preparing their speaking presentation about scaffolding materials. They discuss the properties, advantages, and disadvantages of metal pipes and bamboo.
Hey Risma, have you finished the note for our speaking pass about scaffolding?
Almost. Scaffolding can be made from different material, right? Mainly metal pipes and bamboo.
Yes, let's start with metal pipes. They are strong, durable, and hard. Metal scaffolding can support heavy load and is more stable.
I agree. Another advantage is that metal pipes are fire resistant and can be used many times.
Right, but they also have disadvantage. Metal scaffolding is expensive, heavy, and it can rust if not maintained properly.
That's true. Now, let's talk about bamboo scaffolding. It's light, flexible, and cheap. It's easier to move and set up, especially in rural areas.
Yes, but bamboo isn't strong as metal. It can break or rot in wet weather, and it's not safe for very tall buildings.
Exactly. So we can say metal scaffolding is better for rigid and permanent construction, while bamboo is suitable for small or temporary projects.
Perfect. I think we're ready for our presentation tomorrow.
On a hot morning at the construction site, a red truck loaded with wooden beams arrives. The supervisor checks the delivery and notices something wrong. Some beams are missing and others aren't tied properly.
Morning. Are you delivering the wood for the new building project? Yes, sir. This is the delivery for the construction company. Alright, let me check. Do this. It says here there could be 20 wood beams, but I only count 50. Really? That means I just loaded everything from your warehouse. And look, some of these aren't tied properly. That's danger. Oh, I did notice that I'll fix the right way. Please do. We can't unload them like this. Someone could get hurt. I understand. I will call the warehouse to check about the machine wheels too. Thank you. Safety and accuracy are always our priorities here. Got it, sir. I will make sure everything is correct before unloading.
In the storage room, Yogi comes in to take some cement bags but finds the place messy and disorganized. Arif joins him and together they clean the area to make it safe again.
Hey Yogi, come here. Look at this mess. Who left the place like this?
I think the night shift worker did a clean up after finishing their job.
This is really unsafe. Someone could trip over their tools or breathe in all this dust.
Yeah, I looked some of the cement bed are torn that was of material.
We can work in this condition. We should organize everything fast.
Agree, let's put the door back in their box and sweep the floor.
And we should report this to the supervisor. Maybe we can get new safety storage cells.
Good idea. A clean and safe workplace make all your cases.
Exactly. Safety isn't just the boss' job. It's everyone's responsibility.
You, Rick, let's get start before more people come in here.
One morning, Abdullah from Kawasaki Construction calls Harrogate Solution after realizing his order was delivered to the wrong address. Now, he must quickly find the missing packages himself.
Harrogate Solution, how can I help you?
Hi, my name is Abdullah. I'm calling about an order. There are a few problems with it.
Do you have the order number?
Yes? Yes, of course. It's 102356G.
Just one moment, please. Can I just confirm your company name, please?
Yes, it's Kawasaki Construction.
Thank you. Yes, 3 packages of electrical supplies. It seems that the packages were dispatched at 9 this morning. Just one moment. I'll call up the delivery now. Yes, it was cited for by Mr. Malik Zahid at 10:05.
Malik Zahid? We don't have anyone of that name on our site. What was that delivery address?
34 Ridge Street.
That's the problem. That's not on our side. That's a couple of blocks down. It's a Sun Street, but we are at the number 12.
Oh, I'm sorry about that. I'll shout out a new delivery straight away. It should be reaching tomorrow.
Wait, turn on it. I will send someone down to see Mr. Zahid. I will be quicker. I will call again if I have any problem.
At a busy construction site, Christina Dudek receives more than she expected, way more. When she calls Lopez from the supply company, she's shocked to hear the news. Instead of 3 small bags of sands, 6 huge truckloads have filled the company's car park. It's a delivery disaster that no one saw coming.
Hello. Just one moment, please. Sorry about that. Okay, go ahead. Good, thank you. My name is Christina Dudek. Who I'm speaking to, please? Lopez, how can I help you? I'm calling about a problem with an order. We ordered some sand. Has it arrived? Yes, it's here. That's not the problem. It's if the wrong sand. No, it's the right sand, but it's the wrong quantity. What do you mean? Well, we ordered 10 kilo bags and received 3 truckloads. So, are you saying that we sent you 3 truckloads? Yes, that's right. No, wait. Now we have 6 truckloads. 3 more have just arrived. Where is the sand now? In our car park. Our security guard didn't check the delivery. He just signed for it. Oh no. Oh yes, they unloaded 6 trucks before we could spot the... Did you say unload? Oh no.
It's a moody morning at 7 construction site. The delivery of steel beams is late. The driver's truck is stuck just off the B391. The site supervisor calls to find out what happened. When he learns the driver is trapped in the mud, he quickly sends help. As more and more rain falls, both teams realize it's time to fix the track before the next delivery arrives.
Hello, good morning. This is Alano Baldamero from Sivan Contractor. Could you repeat that, please? I did catch that. This is Alano Baldamero from Sivan Contractor. Oh, yes. Are you calling about the beams? Yes, exactly. Where are they? We're waiting for them. Yes. Well, the driver just called. He's stuck. Sorry? What do you mean? He's stuck in the mud and he cannot move. He say. Okay. Where is he? I'll send someone to pull him out. He just off the B391 about 100 meters down the track to your side. He said he pulled over to let a white lot go past and then he got stuck. Yes, I think I know the spot. We had another delivery stuck there this morning. Can you tell him we'll be there in about half an hour? Yes, thank you. And one more thing? Yes. Any chance you could do something about the track? We'll be sending you more materials tomorrow. Well, it's the rain, but I take your point. I'll see what I can do. Oh, thanks.
In the early afternoon after lunch, Ilham, the site supervisor at the Bintaro project, calls Ladya, the office administrator. The wrong materials have arrived, hollow steel bars instead of galvanized pipes. Checking the order, Ladya discovers he mistypes the addresses as Bintara instead of Bintaro. She immediately apologizes and contacts the driver to correct the delivery, promising Ilham quick update.
Ladya, the material that arrived are worn. I ordered galvanized pipes, not the hollow steel bar.
Wait, let me check. It says the delivery went to Bintara project.
That's the problem. My site is in Bintaro, not Bintara.
Oh no, it means I typed the wrong address in the order form.
Exactly. No, the wrong material are here. My team cannot continue work.
I'm really sorry, Ilham. That was my mistake.
Please make sure this getting correct quickly.
I'll call the driver right now to exchange the shipments.
Okay. Please update me once it's sorted out.
Will do. I truly apologize for the confusion. In the morning, two experts are discussing a BIC engineering problems using a laptop on the table. The Bahrain International Circuit built against a triple threat: sand, speed, and heat. We are reviewing the files that tell how the design team overcame the Sahir Desert's hostility to deliver a Formula One ready track.
Right off, let's look at the final design document. The challenge we are inventing. First, let's talk immediate track integrity. If pull up the topographical, the desert location means concerns and drift, how did stabilize the perimeter and prevent that finds and from compromising the racing line. What did the material specification say? The solution is deceptively simple: artificial grass. To specify this to surround the circuit, it acts as an incredibly effective stabilizer.
stopping desert wind from picking up and depositing sand onto the asphalt. It's a low-maintenance, high-impact material choice. Next, the impossible timeline. Look at this profit start. Delivering a facility of this scale in just 485 days was a construction record. How did we solve the time problem?
This was not material problem. It was a logistic victory. The files confirm a total 8,265,000 man hours we are utilizes. With a speak 2,000 workers on-site simulation, we throw immense human capital at the deadline. The solution was efficiency and scale, not obscure material. Okay, final point. Occupant comfort in extreme heat. We are working 14.5 degrees Celsius plus temperature. How did the building material keep the facilities and grandstand cool? I need the spec on thermal performance.
Okay. We had to engineer thermal envelope. The two circular materials were the roof and the glass. We use 10,800 square meters of high-performance woven membrane for insulation and 7,750 square meters for specialized low E-glass. These materials minimize heat transfer significantly, reduce the cooling load inside. Excellent. So the BIC project proves that this successful desert construction relies on intelligent material selection, Ladya outfit to grass, combined with an aggressive, well-managed allocation of resources. Vascos.
During the daytime, two engineering students discuss which grass barrier construction is better for a racetrack like BIC. In high-speed motorsport, the barrier between a minor incident and a catastrophe is mere inches of engineered material. Today, two student engineers, Althaf and Hasan, compare their contrasting crash barrier designs.
I'll start. My barrier is a high absorption wall, 1.1 meter high. The layout uses tubes stacked 6 high.
Material?
The core is polypropylene tubes, approximately 10 millimeters, held by bullet joints. It's backed a concrete wall and faced with a tall conveyor belt. It's built for maximum cushioning.
I see. Understood. Multi-layer tubes for energy absorption. My barriers is a standard V-beam gut rail. The layout is horizontal steel rail supported by vertical posts. There are spaces between the rail and the posts.
And the materials?
It's primarily galvanized steel for the rail and posts. It's worked by deflecting the vehicle, but it's much simpler, more rigid structure.
Steel W-beam on posts, simpler design. Got it. Let's decide for a high-speed track like the BIC, which is safer.
My rigid steel guardrail poses a rise at high speed. The steel edges and can cause severe damage, and exposures posts are dangerous.
Exactly. My polypropylene tube design is specifically engineered to dissipate extreme energy and reduce G-forces. By crushing and absorbing the impact gradually, it cushions the driver.
I agree. Driver safety is paramount. The high energy absorption of your multi-layer structure is superior to the same simple deflection of my steel rail. Conclusion: the polypropylene, the tube, and conveyor belt barrier is definitely better for a high-speed circuit like the BIC.
Agree. Done.
Do it.
This brings us to the end of our video assignment. Thank you for watching and we appreciate your time and attention. Wassalamu'alaikum warahmatullahi wabarakatuh.